So let's take a look at this example. We're given a curve, y equals square root of 6 plus 2x. And first thing we're going to do is find y prime of x, the first derivative of y. And then we're going to determine at what point on the given curve, which is this, is the tangent line perpendicular to this line. All right, so a little bit of work. Let's go ahead and start with the derivative first. So we're going to rewrite the function. If you want, you can write this as 6 plus 2x. So let me just write that to the power of 1/2. So now we can use the chain rule to find its derivative. So y prime of x is going to be, so we use the power rule, you bring down the power, keep the inside, so that's 6 plus 2x, subtract 1 from the power, so that's 1/2 minus 1. Put them in common denominators, you get negative 1/2. And then we multiply by the derivative of the inside right here. Derivative of 6 is 0, derivative of 2x is 2. Now we simplify. So this is simply 2 over 2 times, changing the square root form, it is square root of 6 plus 2x. And then here we can cancel out the 2 and the 2. So our derivative is simply 1 over the square root of 6 plus 2x. All right, so that is the answer to the first part of this question. Now the next thing we're going to do is find where the tangent line should be perpendicular to this line. So first thing we're going to do is find the slope of this line, because perpendicular means, so two lines are perpendicular if and only if their slopes are negative reciprocals. So once I know the slope of this, I take its negative reciprocal. So let's put that in y equal mx plus b form. So we have 16x plus 4y is equal to 1. I'm going to go ahead and solve for y. So subtract 16x on both sides. We have 4y is equal to negative 16x plus 1. Divide both sides by 4. That will give you y is equal to negative 16x over 4 plus 1/4. All right, so the slope that we need is this one. So we know the slope for this line happens to be negative 16 over 4. That's really 4, negative 4. Now, if you want a perpendicular slope, we're going to be doing the following. So for perpendicular slope, we're going to be negating our slope. So negative 4 and reciprocating that. So that's going to give us positive 1/4. So that's the slope we want. So we take our slope, which is the derivative, set it equal to this number right here. So we're going to go ahead and see when that happens. So we take 1/4, set it equal to our derivative, which is 1 over square root of 6 plus 2x. And then we solve for x. So we're going to go ahead and multiply by 4 on both sides, and then multiply by square root of 6 plus 2x, which will leave you with square root of 6 plus 2x on the left side, and then 4 on the right side. Now take square on both sides, so you'll have 6 plus 2x is equal to 4 squared, which is 16, and then subtract 6 from both sides. Since we're trying to solve for x, this will give you 10, then divide both sides by 2, which will give you x is equal to 5. All right, so when x is equal to 5, our tangent line is going to be perpendicular to that line. Now we want to know what is the point. So that means we need the y coordinate of the point. We know the x coordinate is 5. So to get the y coordinate, we simply plug that into our curve right here. So y coordinate will be given as the square root of 6 plus 2x. I plug in x, which is 5 in this problem, and then I solve for y. So this will give you the square root of 6 plus 5 times 2, that's 10, which will be square root of 16, that's 4. There you have it. Point. So we know x has to be 5, y has to be 4. So the answer to the question, we know x is 5, so the point x is 5, y is 4, as we have solved it right here, 5 comma 4. So that is the point on that curve, square root of 6 plus 2x, where the tangent line is perpendicular to this line. All right, so that answers our question. I hope this makes sense.